Howdy folks, let's go ahead and pick up where we left off. This is the second half of Chapter 7, Memory for Introductory Psychology. I'm Dr. Gabriel Sines, and I'm gonna help you learn a bunch of memory tricks and interesting things. Even though this is the last section for this 4-section PowerPoint, apparently it's half of the PowerPoint, so let's get started. Oh, automaticity. I love automaticity. It's an interesting topic. Automaticity is how, with enough practice, we can start to do things automatically. Memories go from being episodic to semantic down to being so procedural that we don't have to think about them. They just kind of happen. We do them without our conscious processing. The definition for automatic, for something that has become automatic within ourselves, is that we can do it without it requiring almost any mental effort. So if you've ever watched videos of people who are really good and fast at their jobs, they're folks that have worked hard and long enough at their jobs to the point where they can do their work automatically. They don't have to think about it, so they can do it very quickly, and they can kind of just let their bodies do the work. Now, of course, automaticity is beneficial. It lets you walk and talk. It lets you do things that normally you wouldn't be able to do simultaneously because you've perfected one or two of them. So, for example, they say that an amateur is somebody who practices something until they can do it once, but a professional is someone who practices something until they can't do it wrong. And really, that's a pretty dang good example of automaticity. As we've talked about before, procedural memories are so ingrained that they are basically impossible to make mistakes with. Makes sense that once you've practiced something enough that it becomes automatic, it's really hard to mess it up. In the next slide, we're going to have a small experiment. One of those things that you really should try in intro psychology. I wouldn't be a very good teacher of intro psych if I didn't present this experiment to you. What you're going to see is a series of words, 3 columns, and I'd like you to read them out starting from the top left. However, I don't want you to actually read them. What I'd like you to say is for each word, try and say the color of the word, the color of the word that the word is printed in, not the actual word and what it says. So I'll go ahead and do the first one for you, but right after I do the first one, I'd like you to try and do the second and third columns on your own. Again, you're supposed to say the color the word is printed in, not what the word itself says. So here we go. Let's give it a shot. Starting from the top left, not dog, green, blue, yellow, green, blue, red, green, blue, red, green. Okay, give the second and third columns a shot. Pause the video if you want to. 3, 2, 1. Okay, so how did you do? I'm going to go ahead and give it a shot myself. Starting in the middle column, red, yellow, green, blue, yellow, green, blue, red. And the last column, yellow, green, blue, red, green, yellow, blue, red, green, yellow. So it gets harder and harder as you go on. And why does it get harder? Well, obviously this third column has a series of words, color words, but they're printed in different colors than the actual colors themselves. Now, the reason I've got this presented here is because it forces you to work against your automaticity. We read things all the time. When you're driving down the street, you read street signs without even thinking about it. It's really hard to look at words and not read them. So when you look at these words, red, yellow, green, blue, red, blue, yellow, green, blue, red, you want to read the word. But if the task is to say the color of the word, yellow, green, blue, red, green, yellow, blue, red, green, yellow, you're working against your automatic mental processes. This is a test called the Stroop test, which deals with our ability to work with incompatible color and word combinations. And one of the reasons it's hard is because it forces you to work against your automaticity. So automaticity is not always a good thing. Okay, so next up, we're going to try another experiment. This is a test of how good your short-term memory is. You don't need to worry about these instructions. I'll just let you know what they are. So on the next screen, we'll see a star. And after we start it, you will see a series of letters flash up on the screen, and then you'll have a question mark. When you see the question mark, I'd like you to try and write down all the letters you saw in order. We're going to do this a couple of times, and you'll have chances to check yourself after each one. So let's get started. Here's your star. That star shows you where the letters are going to be. Are you ready? 3, 2, 1, watch. Okay, how did that go? Got your answers here, B, Z, T, K. Did you get all of those? That one shouldn't be too hard, but it's going to keep getting harder. Here's your star. Ready, steady, go. Okay, try and write your answers down. I'll give you a moment. Boop, 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 boop. All right, let's see what you got. D, J, R, N, Q, P. Did you get all of those? 6 should start being a little difficult, but you probably should be able to get it. Most folks get 6. If you didn't get it, don't worry, you're not dumb. Maybe you blinked, maybe you mixed them up. It's a law of averages, not so much a law of every time. So let's give it another shot. It's going to get even harder now. Ready? Steady, go. Try and write them out. Okay, let's check our answers. MTXEHVLFCSR. Did you get all of those? This probably is stretching the limits of your attention. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. The same number of letters as there are numbers in a phone number, although usually we can kind of ignore the first 3 because they would be the area code. But let's see if we can do it. The next one should be harder. So let's see if you can just try your best. Try really paying attention. Ready, set, go. Okay, try and write down the letters you remembered. What do you remember? Now I misspoke there and I kind of said words, and that might have tipped you off a little bit. What you saw were frog, bat, pig, duck. A series of quite a few letters, but you might have had an easier time remembering these ones because they were words instead of random letters. So what is it about these words that makes it easier to remember them than a series of this many letters? Presumably this would be really hard since there's more letters now than ever. Well, what's helping you out here is chunking. Our short-term memory can remember 7 plus or minus 2 things. However, those things can be a chunk of information. What is a chunk? A chunk is a meaningful unit of information. So words like frog, bat, pig, and duck are each a chunk. So in that last one, you weren't remembering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 letters, you were remembering 4 words. And so you were actually remembering 4 things instead of those 13 letters. So what counts as a chunk? A chunk could be 1 letter, or it could be a whole word. It could be a section of a phone number. Really, anytime you're working with numbers, it's always easiest to group them in bits of 2 or 3 numbers. A chunk could be an acronym or a part of a word. A chunk could be a person's name. Even a whole sentence or phrase could be a chunk. You can imagine sections of music could be notes or bunches of notes. Depending on how well you can organize the information into meaningful bits, it's easier to remember more and more pieces of information. So if you're ever trying to memorize stuff, try and simplify it down into meaningful bits of information. Okay. So this slide is really intended to deliver this video. This is a very interesting video. I think it's very effective at showing you a lot of different systems about how our memory works that we've learned so far. So I'd like you to give it a watch. I'd like you to watch the whole video. It's a video that's actually about computers and how the internet works, and how we can how do computers and the internet deal with the fact that video, like videos on YouTube, requires a lot of data, but we don't have enough space to transmit all of that data. The reason I'd like you to watch this is because, well, in people, there is an infinite amount of data that we could be working with. Our senses could perceive everything, but they don't, because we have a limited amount of attention. And so much like computers, we have to find ways to use our limited attention to perceive as much as we can, to understand the world as best as we can, without being able to magically have more attention to perceive everything. In computers, the information may change by having the videos slow down, but in people, just like in computers, if there's too much information trying to go through at one moment, you're going to lose some of it. Some of it's going to get discarded. When we don't have enough attention for things, we simply ignore them or forget them. When computers don't have information for things, they make the picture less good or slow it down. So go ahead and give the video a watch, and I'll give you a moment to do so. Pause the video here so you can watch that. You have 3 seconds. 3, 2, 1. Okay, so I hope you've seen the video now, and if it seemed a little bit over your head, let me try and debrief it for you. This list of terms here on the left will help me. So let's talk about short-term limitations. We know that our senses are not capable of taking in all the information in the world, and even beyond that, our ability to process information from our senses is limited. Since our senses can only hold information for a moment or two, there's only a little moment for our brains to process the information. Additionally, if there's too much information, we just won't process it. Can you think of how, that covers sensory memory limitations. Can you think about how this video covers forgetting as well? Well, in the video, we are of course shown different ways in which the information can be ignored or dropped if there's too much information that we're working with. An interesting way to explain organizing data is in the video. They show that we can compress images, lose some information to get the overall picture. We can also simplify the transmission of information, say by saying, oh, nothing changed from 1 second to the next second, or we just moved this information over and changed it a little bit instead of completely sending the information new. In the same way, your brain is very lazy or very effective. By transmitting information in the simplest ways possible, you forget a lot of information. Like, you don't need to remember every time you go to the bathroom, because you can just say, well, that's the same as it was. And we don't remember most of our days, because you can simply remember that today was almost the same as yesterday was. Makes sense that our memories wouldn't want to record all that useless information, so in the same way that computers copy and paste, so do we in our memory. Okay, let's talk mnemonics. I'm sure you've learned about mnemonics already. I'll give you a moment. Can you think of any mnemonics that you've learned of in the past? I've got one mnemonic here already. Oh, That's weird. My phone was just telling me that it's here. Maybe it's haunted. So can you think of any mnemonics on your own? I'll give you a moment to think about it. So maybe it would help if I defined a mnemonic for you. Excuse me. A mnemonic is a way to organize memory information so that it's simpler and easier to remember. In high school, you may have learned this series of equations. One moment. Sorry, my allergies are really acting up. In high school, you may have learned this series of equations representing the ways to identify the lengths and angles of a triangle using geometry. That remembering that series of equations is difficult, so SOHCAHTOA is a mnemonic that helps you remember all of them. Oh, sorry. Excuse me. Gosh, I'm sneezy. Um, how exactly does this mnemonic work? Well, let's think about what it does for this information. Let's say that you want to remember this series of equations. You can imagine that this is a bit of information, and this is a bit of information, and this is a bit of information, and this is a bit of information. And even ignoring all of that, you can imagine that each one of these equations counts as a bunch of different bits of information, because we have this. Oops. I hate how it doesn't always, the writing utensil on this thing doesn't always work. So this is a bit of information, and that's a bit of information, and that's a bit of information, and there's so many bits of information here. How are you going to remember all that stuff? Well, SOHCAHTOA takes all of that stuff and turns it into one chunk. That chunk can again be divided up into these sets of 3 bits, which can be then further divided up into these bits, and they can be further turned into meaningful information. And so the mnemonic here is organizing the information of all of these formulas for you in a very simple, compact package that makes it easier to remember all of them. Makes sense then that this mnemonic, this memory trick, would help you remember all the information by packaging it up into one easy to remember chunk, and that chunk makes it easy to remember the rest of that information. Can you think of any other mnemonics that you've seen in your lifetime? A really common one would be PEMDAS. So the order of operations mnemonic to remember you're supposed to do parentheses, exponents, multiplication, division, addition, and subtraction. Do you know the mnemonic to remember the order of the planets? That's a phrase. I don't remember it because I don't even really know the order of the planets ever, but see if you can Google that one up and learn about it. Some people ask, are mnemonics always these acronyms? Not necessarily. There are a number of different mnemonics you can use, but um, there are many different ways to use mnemonics, but acronyms or phrases that help you remember things are the most common. Let me give you one more example of a mnemonic that you can use right now. So let's learn about retroactive and proactive interference. Retroactive interference is when new information prevents you from remembering old information. Proactive interference is old information preventing you from learning new information. So to give some examples about this, proactive interference, old information prevents new. That could be like if you have learned how to use an iPhone and now you want to learn how to use an Android phone, and it's really hard because you keep trying to do things the iPhone way and it's preventing you from learning the new way of doing it. Can you think of any retroactive interference problems? Well, how about think about all the different countercultures systems that exist. I don't know what the counterculture system is right now, but I know there's hipsters. And do you remember what happened before them? Everyone seems to forget the counterculture that exists because they just remember the current one. Before hipsters, there were emos and goths and then punks, and I don't remember before then, but it makes sense it would be easy to forget the earlier ones because the newer ones kind of take their spot as the counterculture group. Can we think of any other examples of retroactive interference? How about this? Uh, do you remember the first phone number that you had? Do you remember whatever phone number you had growing up with your family? It can be hard to remember that because now you mostly work with your own personal cell phone number, right? So because you know your personal cell phone number, it's harder to remember the original one. Now, retroactive and proactive interference are easy to mix up. They are very commonly mixed up on tests. So can we think of a mnemonic that will help you remember proactive versus retroactive interference? The mnemonic that I've been able to come up with, the one I've seen, is porn. So how is porn going to help you remember proactive versus retroactive interference? Well, let's write it out. So PO, proactive, is old, hurting, new. So that means that proactive means that old information makes it harder to remember new information. So proactive, old prevents new. Retroactive, new hurts old information. That's a terrible arrow. So RN helps you remember that retroactive interference is when your new information wipes out the old information. So there's porn. It's very helpful in remembering proactive versus retroactive, and it's a very perfect example of a mnemonic. Now that I've given you that mnemonic example, let's go back one slide to talk about the serial positioning effect. Let me take a sip here. Okay, so the serial positioning effect is the idea that it's easier and harder to remember different things based on the order in which you learn them or you perceive them. So remember back, if you still have the writing from earlier, remember when we did this this memory test. If you look at this third memory question, which ones of the letters did you remember? It's likely that you remember maybe the first couple letters and the last couple letters better than you remember these middle letters. And why is that? Well, think about the types of interference that are happening. For this first letter, you definitely are going to have interference from these guys, right? So what kind of interference is that going to be? That's going to be, let's see, try porn again. So this is new, hurting, old. So is it proactive? That's PO, old, hurting, new. So it's not proactive, it's retroactive, new, hurting, old. So this first letter is going to have retroactive interference, but there's nothing here. So it will not have proactive interference. And these last letters are going to have proactive interference, but they will not have retroactive interference because there's nothing over here. So, if we clear all this ink out, it's easy to tell that the first letter is going to be more easily remembered, or the first letters are going to be more easily remembered because they have one kind of interference, and the last letters are going to be more easily remembered because they have one kind of interference. But these middle guys are harder to remember because they have both types of interference hurting them. So that's the serial positioning effects. The idea that you remember the first things better, you remember the last things better. The parts in the middle are harder to remember. This isn't just true for lists of letters. For example, if you enter a workplace, the first person you meet, it'll be easy to remember their names, and the last people you meet will be easy to remember their names, but all the people in the middle will be harder. Think about your day. It's easy to remember what it was like waking up, and it's not hard to remember what it was like going to sleep, but all the stuff you did throughout your day is kind of hard to remember because you have both proactive and retroactive interference. Okay, so let's cover some more topics here. Moving on. Retrieval cues. Retrieval cues are the pieces of information that you use when you're trying to remember something. Anytime you try to remember anything, you use retrieval cues. For example, think about your favorite movie. Do you remember what it's called? If I ask you, what is your favorite movie, or what are some of your favorite movies, that is a retrieval cue. It's the bit of information you use to find information in your head. Have you seen the movie? Let's see. Have you seen the movie Coco? The name Coco is the retrieval cue you use to find the information that you have in your head about that movie. If Coco doesn't ring a bell for you, then you probably haven't seen that movie. But if Coco does ring a bell, then you can probably remember bits of what you saw. You can remember whether or not you've seen it. Everything in our memories is organized as a series of interconnected retrieval cues. For example, if you think of bird or birds, that is going to be associated to penguins and dodos and sparrows and ducks. And dodos are going to be related to dinosaurs through, a little bit of an extra path, but it makes sense that dinosaurs wouldn't be directly related to birds in your head. So the information in your mind is organized as kind of this series of connected bits of information. If you've ever made a thought cloud or an idea cloud in high school to help you organize the information you were learning, this is very, very similar. I like to call these neural networks, with each one of these circles being a node and the connections being the network, identifying how they are connected in your head. And we'll learn more about those neural networks in the next chapter. For now, let's think of how we can use retrieval cues in everyday life. We know that if you think of bird, you'll think of penguin. In the same way that during the Stroop test, if you look at a word, you'll automatically try to read it. So, how can we use this information to our benefit? Let's say we're trying to remember something, but we don't remember exactly what it is. For example, let's say you're trying to say something and you suddenly forget a word and you can't remember what that word is. What can you do to help yourself remember that word? Give yourself more retrieval cues. Try to remember, is it a short word or a long word? Does it start with this letter or that letter? Is it a noun or a subject or an object? When was the last time you probably heard that word? How does the word make you feel? Does the word come from another language? Does it have prefixes or suffixes? Just think about as many characteristics about the word as you can remember. And each characteristic that you identify will work or serve as a retrieval cue to help you remember that word. So there you go. The retrieval cues are beneficial to know and understand because the more retrieval cues you give yourself, the more easily you will remember information. As a final example, a multiple choice test is easy. Not necessarily because the test itself is inherently easy, but because a multiple choice test, also because it's a recognition test, but because the multiple choice test gives you a bunch of retrieval cues to work with. You get the question and 4 answers. A recall test, like a short answer test, only gives you the question, giving you fewer retrieval cues to help you find information in your memory. Okay, that brings us to context-specific memory. Context-specific memory is the idea that all memories that you have a context to them. So think about where you're sitting right now. Are you at home watching these videos on your laptop? Well, If you try to remember psychology information in, say, a bus, it'll be harder to remember that information because when you learned this psych stuff, you were at home with your laptop, and on the phone, on the bus, it's going to be a different context. It turns out that all of our memories are always saved in reference to the context they were learned in. Let me give you an example. A series of scuba divers were given a series of flashcards. They learned some of the flashcards on dry land, and they learned some of the flashcards underwater. When they were tested the next day, some of the flashcards were tested on dry land, and some of the flashcards were tested underwater. For the words that they learned underwater and tested underwater, they did really well. For the words where they tested on land and learned on land, they did really well. For the words that were learned in water and tested on land, they didn't do so great. And for the words that they learned on land and tested underwater, they didn't do so great. So if you learned and tested in the same context, your memory was better. Why? Because the context of the memory acts as a retrieval cue. If you are used to only seeing your friend at your favorite bar, and suddenly you walk past them at a grocery store, it might be hard to identify them. It might be hard to remember who they are because the context of who they are is saved alongside where you normally see them, at the bar. If you're trying to learn a language, it can be really easy to remember your French words in French class, but suddenly way harder to remember your French words outside of French class. Why would that be? Well, a big part of that is that the context of the French class gets saved in your memory alongside with those French words, so that you can use the French information when you need it in French class. That way, therefore, if you want to learn French and be fluent with it in any situation, you need to practice your French with a lot of different people in a lot of different places, different times of day, different feelings, when you're happy and sad, when you're tired or when you're awake, all these different times. We've got a video here from early Family Guy that does a good job of presenting the same idea. To summarize, essentially it shows how the main character can play the piano only when he's drunk. So feel free to give that a watch. It's kind of more of a funny one, less so much of a useful one, but I'll give you a moment to watch it now. 3, 2, 1. Okay, moving right along. Let's talk about one of my most favorite topics, consolidation and reconsolidation. If you've ever hit your head and forgotten the things that happened over the last couple of hours, days, or even weeks, what's happened is that your consolidation process was hurt for that period. What is consolidation? Well, when you create long-term memories, it takes some time for those memories to get perfectly saved in your long-term memory. It can take hours or days or even weeks. So the process of consolidation is kind of the process of creating those memories in a permanent way. Whenever you think about a memory, whenever you remember something, you reconsolidate it. So let's say that you had a traumatic experience. After the traumatic experience happens, it might be a day or two before that information is saved permanently in your memory. And during that period of time, the information can be altered. If you think about that traumatic experience, you bring that memory out, and that gives that memory a chance to be altered again, because when it gets saved with the things that you were thinking about. So, for example, if you know someone who likes to tell fishing stories, and every time they tell the story, the fish gets bigger, what's going on there is that they remember the story in their head, they take it out, and then they tell the story, and as that story is getting reconsolidated, they're always going to really emphasize how big the fish was. Because they emphasize the size of the fish, the memory reconsolidates as having a larger fish than it did originally, and that happens over and over again until the fish is ginormous. So reconsolidation is the process of saving memory again, but every time you save that memory, it gets altered just a little bit. There are ways that we can use reconsolidation to our benefit. For example, think about any intrusive thoughts you may have, things that things that you don't want to think about, memories you don't want to remember, stuff that makes you uncomfortable or sad or that bothers you to think about it. How can we deal with these intrusive thoughts? Well, usually they come up because they make us feel anxious. They intrude because we don't want to think about them, but they have something to them that is scary or frustrating or sad that makes us want to think about them. And so if we think about them and let ourselves feel scared or sad, that's going to reconsolidate that memory as worse than it was originally. Because you're going to save the context of, I felt sad when I thought about this, or I felt uncomfortable, or angry or frustrated. A better way to deal with these intrusive thoughts is not to try and ignore them completely, but instead to choose how the reconsolidation goes. Say, for example, you have an intrusive thought, you can put it away and then go for a walk. When you go for a walk, you feel very comfortable and safe. It's nice weather, there's people there, but they're not too close, so if you're in danger, you'll have help, but you won't be bothered by anyone otherwise. You probably will be feeling some endorphins from the light exercise of your walk, and feeling the fresh air will make you feel happy. This is a perfect time to bring about those intrusive thoughts, because when you think about them, you really work through them and mull them over, they're going to be reconsolidated alongside the feeling of comfortable and safeness. That comfortable safeness is going to be saved with those memories, and the next time you think about them, they won't be so bad. So reconsolidation can help us and hurt us. We'll see here in this next slide an example of how reconsolidation can hurt us through source monitoring. This video here does a wonderful job of explaining how new memories can be made that are false memories. Go ahead and give it a watch, and I'll come back and speak to you in a moment. So 3 seconds to pause this video and watch that one. 3, 2, 1. Okay, wasn't that video interesting? I love seeing how they create these false memories in people's heads. Now, what did they do? What aspects of the procedure presented in the video helped create those false memories? This is a wonderful one for your exit slip, so give it a shot. I'll give you a moment to think about it. 3, 2, 1. Well, here's the ones I can come up with off the top of my head. They were asked to they looked at pictures that showed them in the false memory, so that provides visual information that they can then incorporate as having not been visual, but in fact memory information. They are asked to imagine vividly experiencing this memory that they didn't have, which again gets saved in your memory as something that happened, not necessarily something you actually had happened to you. Source monitoring on this slide is the idea that it can be hard to identify where a memory comes from. Maybe someone told you the information, maybe you experienced it, maybe you imagined it, maybe you dreamed it. Memories don't come with a little tag on them that says where did they come from, what time. No. They are just memories. And so the knowledge of did this happen to me, or did I see it in a movie, or did I actually imagine it, is something that we just have to keep track of ourselves. So what are the things in the procedure encouraged these false memories to arise? The vivid imagination of the memory, especially right before bed. We know that right before bed is a wonderful time to study, and it's a wonderful time to create memories, because during sleep you consolidate a lot of the memories that you have. It also prevents a lot of interference, because that's the last thing that you think of. They are told not to talk to their family members about the experiment. So they don't have really any chances to double check, did this actually happen or not. So it's really easy to convince yourself that you did actually ride in a hot air balloon when you were a kid. So source monitoring and false memories can be scary and dangerous, but I do want to give you a PSA before I move on. If you feel if something happens to you that's traumatic, a lot of people avoid talking to someone, talking to the authorities about it, because they are afraid of getting the information wrong. When you talk about these false memories, it's really easy to make people wonder whether they can trust their own memory. So let me tell you this. If something traumatic happens, it is incredibly important that you talk to someone about it. Talk to an authority, talk to a medical professional, whoever you need to talk to, so that you get the help that you deserve. If you're afraid that your story might be flawed due to an imperfect memory, due to the fact that it was a traumatic experience, due to the fact that you're not sure about the source monitoring, know this. The best thing you can do is try and recall the memory as clearly as it happened, as soon after as it happened, and avoid talking to people about it before you do that. Maybe record yourself on your phone or write it down or something. Here's why. If you talk to someone, every time you talk to a policeman, they might ask you something like, was there a gun involved? Did they have tattoos? Da 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 da. This extra information is obviously part of their job, but because they tell you that information, it might get saved alongside the memory and it can distort the memory. Another important aspect to know is that you really want to talk about, in your initial recollection, how confident you are about different things. If there's something you're not sure about or something you really are sure about, that can drastically affect the accuracy of your recollection. Most people have pretty good memory when they say they're sure about it, and most people have worse memory when they're not sure about something. So it's important to include that confidence information. The interesting thing is that if you tell a story with some parts of it that you're not sure about, the next time you tell that story, you'll be more sure about those parts. More and more and more sure about those parts every time you tell the story, because you start to remember telling the story instead of what happened. So that reconsolidation can hurt the accuracy of your story, because telling the story is a memory that you create for yourself as well. So there you go. If you are ever in a situation where something traumatic happens, it's a good idea to record as much information about it as you can, including the confidence you have for that information, and go to an authority as soon as possible. Okay, I don't know why the extra stuff was listed there. We do have one last thing on these slides before we finish out. Eyewitness memory. Eyewitness memory, as you may have heard, is when people testify in court based off what they saw happening in a certain event. And there can be flaws to eyewitness memory. You may have heard that it's something that is often considered untrustworthy. Untrustworthy. Because of all the different memory problems we've talked about so far. I'm going to give you one example for why eyewitness memory might not be so great. And I've already told you examples for why eyewitness memory might actually be really good as long as it is elicited correctly, soon after the event and without opportunities for reconsolidation. So in this experiment, participants watched a film about traffic safety where they saw an accident happen. And after they saw the video, they were asked a question. The question was, how fast were the cars going when they hit each other? Now, some people were asked how fast the cars were going when they hit each other, but other people were asked how fast were the cars going when they contacted each other, or how fast the cars going when they smashed each other. The trick to this experiment is that the people who were asked about the cars that contacted each other usually said that the cars weren't really going that fast. People who were asked about when the cars smashed each other usually said the cars were going faster. Now, everyone saw the same video, so in this case, the phrasing of the question affects the ways in which people answer the question. This is called framing. The way that you ask a question can affect the answer, and it makes a lot of sense that in traumatic cases or in eyewitness memories in court, the way a question gets asked can affect the answer that people give, resulting in potentially inaccurate accounts. So there you go. This is why it's better to record yourself without people asking you questions to avoid any framing problems. Okay, so that's it for chapter 7. There's a lot of material in this chapter, but I hope a lot of it can be useful to you and interesting and beneficial. This has been Gabriel Science, and I hope you have a wonderful day. Bye-bye.